Let's begin. Today's July 8th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses 5 criteria cards and its 5 verification cards. Let's go to turingmachine.info for the details. So today's puzzle uses the following 5 criteria cards. Criteria card 5, 8, 12, 17, and 20. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got the 5 criteria cards. On the top row, we've got criteria card A, criteria card B, criteria card C, and on the bottom row, we've got criteria card D and criteria card E. So criteria card A looks at our first digit, the triangle digit, and the Turing Machine will let us know whether that value should be an even digit or an odd digit. Criteria card B looks at our 3-digit solution and will let us know how many of those digits should be 1. Should there be no 1? Should there be a single 1? Perhaps 2, maybe even all 3 should be 1. Criteria card C looks at our first and last digit, triangle and circle, and the Turing Machine is comparing them. So should the triangle value be less than circle? Should the triangle and circle be equal to each other? Or should triangle be greater than circle? And criteria card D, again, looks at our 3-digit solution. And the Turing Machine will let us know how many of those digits should be even. Should there be no even? A single even? Perhaps 2 even? Maybe even all 3 should be even. And criteria card E, again, looks at the 3-digit solution and will let us know a little bit about the structure of the solution. Specifically, are there no repetitions, meaning that all digits are unique, as in the example 1, 2, 5. Perhaps it may be a double number where there is a repeating digit, as in the example 1, 1, 2, or maybe even it could be a triple number, where it's a single digit repeated 3 times. Remember, the objective of today's puzzle is to find that one unique 3-digit code that abides by all of the all of the 5 criteria cards that we just discussed. And again, we're going to start with our initial proposal of 314. So the first thing I want to test is I want to know a little bit about that triangle digit, our first digit. So let me go ahead and test criteria card A. Okay, so the Turing Machine approves of what I have for triangle. Notice I did choose an odd 3. So the Turing Machine confirms at least that it's odd. Perhaps maybe not 3, but odd nonetheless. So let me go ahead and put that in my notes. That triangle is an odd digit. And since it is an odd digit, that means I can cross out both evens. I'll cross out 2 and 4. Okay, so, and notice that we do have this criteria card D, where it tells us how many evens. So obviously the maximum would be 2, because that's what I have left. I do have 1. So let's see, if I were to pick it and I get an X, obviously it can't be 3 and it can't be 0. Can't be 3 and it can't be 0. Oh wait, why can't it be 0? It could be 0. Yeah, it just can't be 3. Okay. And also notice, I just noticed that none of the criteria cards ever mention square. So that's very interesting. So somehow it's going to be forced into, a particular value based on perhaps these 3 criteria cards, B, D, and E somehow. Perhaps it could be the only even. So that said, actually, let me do this. Let me actually test criteria card E to see a little bit about its structure. So let's see if we can get any details. Okay, so it does not approve of what I have. Remember, I do have 314, those are all distinct digits. So that means it's not a no repetition type of structure. So that means that it must be either a double or a triple. So let me go ahead and type that up in my notes in section E, that the solution is a double or triple number. Okay, and let's see. Since we do know that triangle is odd, and if it were to be a triple number, that would mean that they would all be odd. Therefore, I believe making criteria card D, irrelevant, because if we know that it's a triple number and they're all odd, that means that we would know that there would be 0 even. I think for that fact, I think it's okay to cross out triple, or state that it's not a triple number, that indeed it must be a double. So that leads us with either it could be two odds, and like I mentioned, it could be somehow triangle and circle. Notice that we are comparing them. That would be an opportunity for it to be equal, and then circle might be that even. So let's see, what would happen if triangle and circle were equal to each other? Do we have enough information to be able to figure out what square might be? It might be, there might be an even, but which one would it be? 2 or 4? I just don't see any way where we could figure that out. And almost same thing about what if it were odd? I guess maybe there could be a single one and then somehow the others would be equal, but even then, what indication do we have that they'd be a 5-5 or a 3-3 or a 1-1 for triangle and circle? So I don't think they're going to be equal. In fact, I just don't see that happening. So it might be good to be able to compare them. So let's go ahead and do that. Let's compare triangle and circle, and that would be criteria card C. Okay, so it is true, or at least that Turing Machine approves of my triangle and circle. Notice again that triangle is 3 and circle is 4. So the Turing Machine just confirmed that yes, triangle should be less than circle. So let me go ahead and type that up. And that was criteria card C. And again, that is that triangle should be less than circle. And so what that means is that we can actually cross out some values. It means that triangle cannot be a 5, because if it were to be the smallest of the two and it's a 5, what would circle be? There's nothing bigger than 5. And similarly, circle can't be a 1 because, again, if it's supposed to be the largest, there is nothing smaller than 1. So we're able to cross that out. Okay, so I think that does it for this round. We're now going into the phase where we'll be kind of discussing a little bit more strategy on how to find a good second round proposal. Okay, so what we didn't test was B, figuring out how many 1s there are. Notice that there are still 2 1s. And what else didn't we test? We didn't test D, the number of even. So notice that we do have the 2 1s available. So that would be interesting. That would sort of force triangle and square to be even, both 1s, since they're the ones available. And then we could either have no even, a single even, or one more odd and that would be circle. So let's see, what would happen if there were two ones? What would that look like? Or what would that leave us for circle? So again, if it is a 1, then everything else is larger. 2, 3, 4, and 5 are all up for grabs. And I think regardless of whether it's an even or odd, I just don't see how we'd be able to pick among 2, 3, 4, and 5. So for that fact, I don't think there could be two ones. Because again, I can't see a way to be able to choose among 2, 3, 4, and 5 using any, or all of the available criteria cards. So there aren't two ones. What if there's a single one? And if that were the case, that would mean that, of course, it couldn't be triangle and circle to be equal. It would either be triangle and square, or square and circle. So if it were triangle and square, the only other possibility would be 3, 3. But if that were the case, if it's 3, 3, then we know there wouldn't be any ones. And if that were the case, so that's an interesting, it could be 3, 3, 5, where there are no evens. And since you've already said that there are no ones, and there had to be a pair, it could be 3, 3, 5. That's a possibility. And yeah, because it can't be triangle and circle being the same. Oh, okay. Yeah, and of course, 3, 3, 5, since, circle is greater. Let's not forget that. So let's see. Is there any other possibility? So what about square and circle being the same? So again, circle has to be greater. So it could be that there could be two evens. Yeah, another possibility is if there are two evens and no one, it could actually be 3, 4, 4. So I'm really leaning into somehow it's either 3, 4, 4 or 3, 5, 5 based on what I see. So let's go with the original 3, 5, 5. Let's go with that. Let's see where that takes us. 3, 3, 5. Okay, so let's see. Yeah, let's go ahead and test the number of evens, since we already know that triangle is odd. So let's go ahead and do that. Okay. Yeah, let's do criteria card D. Okay, so it's not true that there are no evens. So there's at least 1 or 2. So that is interesting. Okay, so let's go ahead and update the notes and say, let's see, so I didn't have any, so it's not true that there are 0. So there's either 1 or 2 evens. So there. Either 1 or 2 evens. Okay, since again we do have a pair, it could be that we have a pair of odds and a single even, or the triangle is odd and square and circle are even. So that really did narrow things down. So I'm kind of leaning maybe that it could be 3, 4, 4. Let's now test criteria card B for the number of ones. And okay, so it's true that there are no ones. Okay, notice that in my proposal I have no ones. The Turing machine just confirmed that. So we'll say in B, there are no ones. And so let's go ahead and cross out the ones that we do have. So yeah, so we've already kind of established that triangle must be 3. Okay. And let's see, if we do have that 3, we know that circle can't be 3. Okay, so let's do this. Let's update our circles, because since we've already established triangle to be 3, and we know triangle needs to be less than, we know circle can't be 2, and we know circle can't be 3. Okay. And let's see, what about the fact that, okay, so that would mean that either it's 3, so yeah, let's do this. Let's list the available possibilities. So we know triangle is 3. If triangle and square are equal, then it would be 3, 3, and then either 4, but not 3, 3, 5, since we know that there has to be at least one even. So I believe that's it for triangle and square being equal. 3, 3, 4, not 3, 3, 5. And actually, I think I meant to type 3, 5, 5, to be honest. I don't remember anymore. But regardless, it still would have given us the X on D. Okay, so we need at least one even or two evens. So, and besides triangle and square being equal, then it would be square and circle. And so I think again, I don't think it would be 3, 5, 5, because again it would fail for D. So I think that must be the answer, 3, 3, 4. That seems like the only, well, what about, oh no, what about 3, 4, 4? Yeah, I think that's the other one, that it could be where that's 2 evens. So yes, so triangle, square are equal, so 3, 3, 4, or square and circle are equal, and the only possibility is 4, 4. Yeah, so I think this square 2 is, I think, out of bounds, because it is neither equal to either triangle and circle, and we need that. But I'll leave it at that. Okay, so we do need to go to one more turn, unfortunately, because the one criteria card that I need to test, I just tested this turn, and that is criteria card D. That's the last one. Yeah, because we've already sort of established E to be a double number. So I do have to go to a third round, which is unfortunate, but necessary. So let's go ahead and let's see, which one would be a better choice? 3, 3, 4 or 3, 4, 4? What would be, is there any way even to deduce that? I just don't see it. So let me go ahead and do 3, 4, 4. Let's just do 3, 4, 4. Or actually, first I need to say I'm going to a next round. So I'm going to type in N. And so now it's prompting me for the 3-digit proposal. And again, I'll say 3, 4, 4. And I'll test D to query how many evens there are. Okay, so yes, it does agree that there should be 2 evens, and therefore it must be 3, 4, 4. So let me go ahead and cross this option out, and let me type up 3, 4, 4. And so let's see, really quick, yes, triangle is odd. There are no ones. It is true that triangle is less than circle, the first and last. Oh, okay. So yeah, we just established by querying D again that there are indeed um, two evens. Let me cross this out. There are two evens and there is a double. Okay. So it looks great. So let's go to turingmachine.info and verify. So we have 3, 4, 4. And let's see how we did. Yes, okay, great. But let's actually test. So here's where my concern is, the fact that we went to 3 rounds, even though we just did 6 tests. But that's just the way it is. So we did ACE the first round, and then BD the second round, and then D again on the third. So ACE. So ACE, and then we did BD, and then finally we confirmed D was correct. And yes, unfortunately, oh, this is interesting. Yeah, I think may have seen this before. So I did get the right number of questions. We tied on the questions, but sort of the tiebreaker is the number of rounds. So the Turing Machine did it in 2 rounds, exactly 3 queries each. I had to sort of exit the second round because the criteria card that I wanted to query I had just used. So that's an interesting gameplay strategy. Sometimes maybe, yeah, obviously if I had tested D, say in the first round, that would at least leave it available for the second round. So maybe in the future, be cautious of not testing, say something like criteria card B or D, which have 4 possibilities, to maybe play at least one of them in the first round so that they become again available in the second round. But if you notice anything else that might be helpful for gameplay strategy, I would appreciate getting those notes. And if you did like the video, please give it a thumbs up. And if you don't want to miss out on any future videos, please hit subscribe to be notified. Well, until next time, have a great one.